In December 2013, the largest tunnelling machine ever built stopped moving under downtown Seattle. 57.5 feet across, nearly 7,000 tons, $80 million built for exactly this ground. What stopped her, according to the company that ran her, was an 8-inch steel pipe. The state had drilled that pipe into the ground itself 11 years earlier, and in the project's files, its depth was recorded in a spreadsheet under a column labelled PVC, plastic. The fight over that one word ran 6 years and over $500 million in claims. Here is what the record actually says, and what nobody ever decided. February 28, 2001. A magnitude 6.8 earthquake rolls through Puget Sound, and Seattle's waterfront highway, a double-deck concrete viaduct from 1953, cracks. One bore, 2 miles, under downtown. The state hired a contracting team, Seattle Tunnel Partners, at a fixed price of $1.35 billion. If building it cost more than that, the problem was theirs. And because no machine on Earth could cut a bore this size, they ordered one from Hitachi Zosen of Osaka. A cutting face 57.5 feet across, studded with hundreds of tools, driven by 24 electric motors. Longer than a football field. Washington school children named her Bertha, after Seattle's first female mayor. July 30th, 2013. Bertha starts digging. 29 months to cross under the city, along a route sampled by 589 borings. Soil logs, test wells, decades of records. The story turns on 2 of them, 11 years before launch, 2002. The earthquake studies are underway, the same studies that will eventually justify the tunnel. The state's geotechnical consultant sinks a test well near South Main Street to watch the groundwater. Well number 2, TW2. Along this corridor, 587 of the borings were drilled with rotary rigs and lined, where they were lined at all, in plastic. TW2 was one of 2 drilled the old way, cable tool, and cased in steel. 8 inches wide, over 100 feet deep. When the consultant logged it, the depth went into a computer listing under a heading that read depth_bottom_PVC. The well itself was no secret. Bidders could find its location in the project's data reports. What the contract's baseline documents never said, and the state later formally admitted this in court, was that the casing was steel. So, in the summer of 2013, the largest tunnelling machine ever built began driving toward an 8-inch steel post that the paperwork filed under plastic. She would reach it in 4 months. The first 1,000 feet were not clean. A 7-foot sinkhole opened along the route in November. There were stops for clogging, and the project's records from those early months describe wear on the cutter head. Remember that the machine was 4 months old. By early December though, she was posting the best numbers of the entire drive. The project's own inspection records, later published by Seattle station KUOW, tell that week day by day. Tuesday, December 3rd. Bertha's best day ever, 59 feet. An inspection that day notes the main bearing area looks healthy. Quote, lots of grease present. Wednesday, December 4th. Something starts coming up the conveyor that is not soil. Steel. Torn lengths of it. Then, a chunk of boulder or concrete. Then, more steel. The crew pulls the debris off the belt and keeps mining. Thursday, December 5th. The machine slows badly. 4 feet of progress in a day. And around the main bearing, the readings that day put temperatures near 150 degrees Fahrenheit, roughly half again what was normal. Friday, December 6th. An inspector finds grease leaking from one joint and spraying from another, and in the grease, sand. Grease is what stands between a 10-meter bearing and the ground it spins against. It lives behind a ring of rubber seals whose entire job is to keep the lubrication in and the earth out. Sand in the grease meant the outside world had found a way through. They shut her down. 1,000 feet into a 9,270-foot drive. The public was told the machine had hit an obstruction, and for a month Seattle guessed. Boulders, wreckage from the old waterfront, something no map remembered. The state did not have to guess. Within 3 days of the shutdown, its engineers had matched the steel on the conveyor to their own records. TW2, their own test well, from their own earthquake studies. They knew in December. The city found out in January. Sit with that gap for a moment. For a month, while the region speculated about buried locomotives and glacial boulders, the answer sat in a filing system in Olympia, 8 inches wide and 11 years old. When the announcement finally came, it did not end the argument. It started one. The argument that consumed the next 6 years comes down to one assembly, so look at it closely. The whole cutting face spins on a single bearing, 10 meters across, made in Germany, a $5 million component. Between that bearing and the pressurized abrasive muck at the face sits the seal system. Concentric rings of rubber lips with pressurized grease between them. The same principle as the seal on your car's axle, scaled up to the size of a house. If a seal lip deforms, abrasive soil migrates into the grease, then into the gear chamber. It grinds, it heats, and steel machined to millimeter tolerances starts eating itself. When the front of the machine was eventually opened, the record shows what they found. Cutting tools worn down, the cutter head structure itself abraded. Soil contamination through the failed seals had damaged the ball gear, the bearing rollers, and the pinions on every one of the 24 drive motors. The center pipe of the cutter head assembly had to be rebuilt from scratch. Press reports, citing the inspections, said parts of the seal casings had broken apart and sent fragments into the drive gears. This was not a machine with a dented face. Its core had been contaminated. And that is where the 8-inch pipe stops being a simple story. Worn tools and abraded steel take time. The files held entries from before December. The clogging, a deformation of the cutter head, a crack in the center pipe. And, according to filings the machine's insurers later made in court, reports from Hitachi Zosen's own staff that November describing abnormal wear. The manufacturer has always maintained the machine left Osaka, in its executive's word, perfect, though press accounts reported the seal assembly had needed repairs during factory testing in Japan. Had the pipe wrecked the machine in 3 days? Or had the machine been failing for months, with the pipe arriving just in time to take the blame? Depending on the answer, someone owed someone else $500 million. You cannot tow a nearly 7,000-ton machine backwards out of its own tunnel, and you cannot change a 10-meter bearing from inside one. The engineers chose the only direction left, down. In front of the stalled machine, crews sank a shaft 120 feet deep and 80 feet across, walled with 75 interlocking concrete piles. The plan was for Bertha to complete her own rescue, mining forward through a 20-foot concrete wall into the open shaft, where a crane could finally reach her. Digging that shaft meant pumping the groundwater out from under Pioneer Square, and for a few weeks in late 2014, the neighbourhood and the viaduct itself settled, by the state's own measure, about 1.25 inches, before the pumping was slowed and the ground steadied. The rescue of the tunnel machine had briefly threatened the highway it was meant to replace. Then the lift. A custom gantry, 1,300 tons of steel standing on 48 hydraulic legs, straddled the shaft. On March 30th, 2015, it raised the machine's entire front end, 2,000 tons of cutter head and drive, up out of the shaft to daylight, turning it flat in mid-air on the way. 16 hours start to finish. On the surface, Hitachi Zosen's engineers rebuilt their machine in the open air. The spare main bearing the contract had required, a redesigned seal system inside and out, and 86 tons of new steel stiffening the structure that had flexed. That redesign is worth pausing on. You do not add 86 tons of reinforcement to a design you believe was adequate. The manufacturer said the changes proved nothing about the original. Others would disagree in court. Bertha went back underground in December 2015, 2 years after she stopped, and this time she finished. Under the viaduct, under downtown. On April 4th, 2017, she broke into the receiving pit near the Space Needle, 9,270 feet from where she started. The tunnel opened to traffic in February 2019, 3 years late. Bertha herself was cut apart and hauled away. She was built for one drive. The machine's story was over. The fight about her was reaching its main event. 2015, a 3-expert dispute review board heard both sides. Their findings? None of the state's people at the hearing had known the steel casing existed before the machine hit it. The state had run a pump test in that very well 3 months before bidding opened, and the computer listing filed its depth under PVC. Their conclusion? The pipe was a differing site condition, the state's responsibility. But the board explicitly declined to say whether the pipe had caused the breakdown, and its finding wasn't binding. The state rejected it. Before trial, something surfaced that damaged the contractor badly. Of the 9 recovered pieces of the pipe, 7 had been thrown into a scrap dumpster during a yard cleanup, along with 2 boulders pulled from the same chamber. A deputy project manager's journal covering the critical weeks had gone missing. The judge found the loss of evidence was, quote, not innocent or accidental, and instructed the jury it could hold that against the contractor. Autumn 2019, 9 weeks of trial. The contractor's claims, filed at figures as high as $642 million, had been capped by the judge at $300 million. The state counterclaimed for its delay damages, and its lawyers went at the pipe theory head-on. The pipe, said the state's lead counsel, was nothing more than a toothpick to the TBM. The real problem, he argued, was operation. Crews failing to keep the excavated soil conditioned to the consistency the machine needed, letting the cutter head clog and strain. The contractor's lawyer answered the toothpick line directly. I don't know if he'd like to use that as a toothpick. I wouldn't want to use it. And the state had answers on the disclosure question too. A data supplement from 2003, outside the contract's baseline documents, had described the casing as steel, and records surfaced at trial showing the contractor's own crews had found and logged the top of the pipe twice before the dig began. The jury deliberated for less than a day. Question 1 on the verdict form: was the steel well casing a differing site condition? Answer: no. And because of that answer, question 2, whether the pipe caused the damage, was never reached. Not answered. Left blank. The jury awarded the state $57.2 million for for 867 days of delay. Appeals ran 3 more years and changed only the interest, about $77 million owed to the state, final in 2022. Look at that verdict form once more. The industry's neutral experts said the pipe was the state's mistake and declined to rule on what it broke. The jury said the contractor's claim failed and never reached what broke the machine. 2 tribunals, 6 years apart, and the actual engineering question passed through both of them untouched. Nobody, anywhere, ever ruled on what stopped Bertha. There is a third version of the story, and it belongs to the insurers. Their engineers, a Berlin tunnelling consultancy, examined the machine and concluded, in their words, that it was improperly designed, underdimensioned, its outer seal ring deforming and running short of grease from early in the dig. The manufacturer rejected all of it. In court filings, the insurers went further, alleging, on the basis of internal memos, that contractor and manufacturer had agreed to present a solid front blaming the pipe. The manufacturer called that a baseless conspiracy theory. A jury was finally set to weigh it all in 2024. On the second day of trial, the case settled, terms confidential. So, the pipe, the seals, or the operators? 3 theories, each argued by professionals with hundreds of millions at stake. The settlements that might have tested them are sealed. What the industry took from Seattle is concrete enough. Baseline reports on later mega projects began spelling out what earlier ones left implicit, and bidders learned to ask a blunt question about any corridor. What did we ourselves leave down there? 8 inches of steel, filed under plastic, turned out to be an expensive filing error to argue about. Today the tunnel carries its traffic through a tube 52 feet across inside, about 90 feet under the city, and nobody driving it has any reason to notice South Main Street. But under that pavement, the rescue shaft is still there, backfilled and capped. A 120-foot concrete room built to lift the world's largest tunnelling machine into daylight and send her back down repaired. The verdict is final. The engineering question never got its answer. Below grade, the file stays open.